So our next speakers, we actually have two coming on board here, are Thomas Starkey-Owens and Kaitlyn from the Yurok Tribe Environmental Department. And they're picking up the theme that we've heard several times and that Randy started today with, which is the impacts of drought and climate change and their direct observed experience of that. So I'm looking forward to their talk, and take it away, please.
Great, thank you so much for the introduction. I'm trying to share my presentation, but it seems like things have frozen. Oh,
I'll let you know when it pops up there.
okay.
It looks like it's trying hard.
Yeah, my computer is not participating with me at the moment.
Well, that is everyone's nightmare.
Yeah, Thomas, we see a screen that's saying you're starting screen sharing.
Maybe click out and try again would be a suggestion.
Oh, there you go. Something seems to have worked. Can you see my screen?
You're good.
Okay, great. Well, thanks again for the introduction. My name is Thomas. I work for the Yurok Environmental Department, and I'm here with my colleague, Kaitlyn Wolling, who will be presenting on some long-term monitoring data sets today. And so I'll just hop straight into it. I think there's a bit of a lag, but I think it should change slides. So the Yurok tribe is based in the Northern California, or based within Northern California along the coast. Their ancestral territory includes the lower portion of the Klamath River, as well as coastal regions stretching from Damnation Creek to Trinidad. However, the reservation boundary is adjacent, or runs adjacent to the Klamath River along the lower 44 miles, about a mile on either side of the river. Federally recognized in 1993, the Tribal Environmental Department started monitoring and collecting various sorts of data, including water quantity and quality. However, it really wasn't until the 2002 fish kill that the Environmental Department really revamped and kicked up their monitoring efforts, particularly in the main stem of the Klamath River, but it also included some hydrologic monitoring efforts within the tributaries of the lower Klamath region. So since its creation, the Environmental Department's mission has been to protect lands, air, and water resources for future generations of tribal members. And one of the goals of the Community and Ecosystems program of the Environmental Department was to really gather data on drought and the impacts of drought, which has been a common theme in talks today. Are my slides changing? Is that?
No, they are not, Thomas. I have them up as oh, there we go.
Okay.
They're working now.
Sweet. Sorry about that. So back on it, the Community and Ecosystems program really started collecting information on the impacts of drought in 2008, and it wasn't until a decade later in 2017 that the environmental program produced the Climate Adaptation Plan, which is an awesome document that lists both tribal staff observations as well as tribal elder observations of the impacts of drought within the basin and on and adjacent to the reservation, which these impacts have been listed by our speakers today already, but they include anything from stresses on aquatic and terrestrial ecosystems, loss of biodiversity, and loss of fisheries, as well as pressure on domestic water supply use and the obvious looming threat of fire within the Klamath region. Some of the major tributaries that the environmental program focuses on monitoring include some of the lower 44-mile tributaries like Blue Creek, Turwer Creek, Mcgarvey, and Pequon Creek, some of which have been highlighted today. And for the purposes of this presentation, we're going to be focusing on a subset of the tributaries that we have hydrologic data for, as well as long-term water quality data in the form of benthic macroinvertebrates. And for the purposes of this presentation, we're describing intermittency as a stretch of reach that undergoes periods of dryness or that goes subsurface. So for example, at Lower Turward Creek, we might have a stretch of turward that goes subsurface or dries. However, the upper portions of the headwaters of that stream might still retain water keep perennial for the whole year. And with that, I'm going to pass it off to Kaitlyn Woolling.
All right, thank you very much. So like Thomas said, we're going to focus on tributaries that have long-term discharge and BMI data. So I'm only going to talk about 2 tributaries today. The first one being Blue Creek, and it's a very large tributary to the Klamath River. It's my background in the Zoom presentation. So it is snowmelt fed. Its drainage area is about 80,000 acres, and it's a perennial stream. So what I have here is a flow duration curve, and it's kind of cut off at the bottom, but I have percents listed at the bottom, and this is a time-weighted flow duration curve, and it's zoomed in to the lowermost discharge values, and it's only showing between 95 and 99%. It is showing the discharge values for 95 to 99% of the time. Let me rephrase that. 95 to 99% of the time, the discharge values are at or exceed the values on the y-axis. So what I have is from 2003, the lines are light, and then each consecutive year is shaded a slightly different or darker color. 2021, it's at the bottom of this curve, and you can see pretty low discharge values. But Blue Creek, being a perennial stream, it's not really showing huge trends in huge trends in recession over the years. Whereas, next slide, please. We'll see how long this takes. All right, whereas Mcgarvey Creek, which is a creek that Jimmy talked about earlier, that is showing a really clear trend in increasing intermittency over the years. And I'd like to point out that Mcgarvey Creek is a smaller watershed. It's about 5,500 acres, and it's prime coho habitat. There's a lot of fine sediment in the system, and there's a lot of occurring timber harvest still going on. But there are restoration projects going on, such as Jimmy and the Yurok Fisheries BDA restoration efforts. But so what does this trend towards intermittency and lower discharge values in these certain tributaries, what does that mean for biota? So that's something Thomas is going to answer. So back to you, Thomas.
Thanks. So Kaitlyn pointed out that, increasing intermittency is something that's both observable by staff as well as within communication with tribal members who have been living within the reservation or within Yurok ancestral territory for years and generations. And there's a plethora of literature out there that I'm not going to list out each of these points individually, but there's lots of literature that suggests that benthic invertebrates, in the same way that can change their composition based on water quality parameters, that based on the length of their life cycles, they can change their compositions based on the presence of surface water, right? So being in intermittent streams versus perennial streams, you would expect to find different compositions of invertebrates, more generalist taxa, for example, or shorter life cycle taxa. But there's one article in general or in particular that I want to highlight, and that was a particular interest for this analysis, which was a paper by David Herbst from the Sierra Mountains that the title is listed here, and I'm happy to share with anybody afterwards. So the environmental program, benthic macroinvertebrate monitoring program or project, follows standard swamp protocols. Again, I'm not going to list all the bullet points here just for time's sake, but we do use standard procedures like selecting 100 to 200 meter reaches, using D-frame kick nets, 500 micron mesh size, preserved with 95% ethanol. And a quick shout out to John Lee Taxonomic Services based out of Eureka, California, who he really has been with the environmental program since the first sample that was collected back in like 2001 or 2002, and has processed these samples for the program and has really provided a huge amount of support. So shout out to him. And on to some of the preliminary results. So we took this theme of drought and took this decade plus long data set of benthic macroinvertebrates in the lower tributaries. And some of the preliminary findings suggest that the intermittent sites that we're calling intermittent, or the sites that go subsurface and dry, tended to score lower in diversity, as well as have lower NorCal index of biological integrity scores or index scores. And you know, this wasn't a shocker to us, right? Like the literature is there to suggest that this is expected, right? Like a site that's intermittent isn't going to be able to support the same long-lived taxa that require water for years in order to mature and morph into their adult stages in the same way that a perennial stream is able to support. And so we wanted to follow that up with some other questions, like how does the flow duration or the change in flow duration due to drought impact those scores and impact the BMI compositions? And in order to kind of get at that question, we were able to use Kaitlyn's flow duration statistics that are produced from these tributaries and from the environmental department's gauge networks. We used the 50% exceedance values for each of these curves. We grouped the streams, or we grouped the data by stream type, perennial or intermittent, and water year, by dry year or wet year, and use standard multivariate statistic methods to further analyze the data. And so using the same climate adaptation plan that was mentioned in the beginning of our presentation, we were able to group the last 11 or so years, or 11 or so water years, based on dry and wet years between intermittent and perennial streams. And it looks something like this. This is also informed by the Trinity River Restoration Program's water year classifications that you can find on their website based on inflow into reservoirs upstream of our rivers. And so this is how we grouped our water years and our multivariate data set. And after producing that and displaying it into ordination space, what we were able to find was that perennial streams, regardless of dry or wet years, really showed minimal differences. There's a high degree of overlap, and there's not a huge amount of evidence to suggest locational or compositional differences in perennial sites, regardless of wet or dry years. However, there is a good amount of evidence to suggest compositional differences in intermittent sites between dry and wet years. And that's largely driven by a high degree or high abundance of collector-gatherer taxa, or at least small. They tend to be small, short-lived, usually multivoltine invertebrate taxa that can produce multiple generations in a year, or only take about a year to mature. And following an indicator species analysis, which, armed with that knowledge of differences between intermittent streams during dry and wet years, the indicator species analysis allows us to identify certain taxa that drive those compositional differences. And what we were able to identify were specific taxa, in this case, chironomids, which is a tiny midge that's highly associated with impacted streams, and they're generalist taxa. They're pretty much ubiquitous in all streams, even if it's incredibly intermittent and temporary water, as well as Sualia, which again is a small taxa that don't take a whole lot of time to mature. Neophylax, which is the same idea. It's a caddisfly that is specifically adapted to a period of drying where like you can find caddisfly shells glued on the sides of rocks, even in dry streams. And usually that's the pupa or the puparium of that particular taxa, and it's adapted to a drying system. Whereas your bigger, larger taxa that take a couple years were indicators of those perennial systems, both during dry and wet years, like your big classic Calinuaria stonefly or your riffle beetles that have like adult stages, fully aquatic adult stages. And kind of unintentionally, what we were also able to find was something that Kaitlyn highlighted, which was that, you know, we have these differences between our intermittent sites. However, there's also evidence that some of our historically perennial streams like Mcgarvey are slowly inching towards similarity with our intermittent sites during wet years. And so, you know, this is of particular interest to us, thinking that, you know, these historically perennial sections of tributaries that are well known to bear fish and are important, and are sites of oftentimes for like restoration, including like the Mcgarvey BDAs. This has implications for fisheries as well, either in the form of food resources for them or just the lower biodiversity in BMIs that you can find within these drying perennial sections of stream over the last 2 decades. And so just to kind of beginning to wrap up, you know, some of these findings kind of lead to next questions that we're interested in asking within our tributaries, including how do upstream perennial reaches contribute to BMIs colonizing downstream reaches that that will typically dry. So in this case, the upper Turwer perennial reach, how do those perennial bugs influence the colonization of reaches downstream of it? And what we're also interested in is how in-stream restoration projects that are designed to improve surface flows, how do those change a impacted reach or historically perennial reach that is subject to drying now? Like how do those impact the BMIs there, the generalist taxa that have kind of persisted, whereas the more sensitive, larger taxa do not? So how do restoration activities influence those compositions of invertebrates? And taking what we learned from downstream, we're also beginning in the beginning process of studying upriver tributaries, these smaller tributaries that are identified as at risk or are subject to drying, either in the form of springs that have dried, or just, you know, a smaller quantity of water available. And we've begun to identify study sites where we want to collect benthic macroinvertebrate samples and use those same indicator taxa to pick and choose like which streams can be highlighted as at risk and in need of potential restoration or different management actions. And we're doing this by studying kind of like the mechanistic process of headwater tributaries, or headwater wetland systems and headwater ponds as like holding reservoirs or for water and for spring systems, and how do those influence flow duration in downstream reaches. And we're doing that with temporary stream gauges installed at the creek mouths, as well as within these ponds and spring sources. And we're trying to be opportunistic with it, with various restoration methods that are occurring in the upriver community, either through restorative fires or cultural burns, and wetland restorations or beaver dam analogs. We want to further understand how the use of these restoration activities can impact or potentially impact flow duration during those extended periods of drought. And if the BMI compositions show that or can change in conjunction with those management actions. So there's a lot of acknowledgements. I want to thank the entire Yurok Environmental Department staff and our supervisor, Matt Hannington, who's also on the steering committee for K-Bump. It's been a pleasure working with the Environmental Department, and I hope to keep working with the invertebrate data for the next few years, because there's a lot of promising project monitoring projects going on in our neck of the woods. So with that, I think could open it up with questions. And there's also, Kaitlyn mentioned that it would be a good idea to drop a link to a web portal that we have. It's a public web portal where you can access and view a lot of our hydrology data from these tributaries that we study every day. So thank you.
Kaitlyn and Thomas, thank you very much. And food webs and macroinvertebrates seems to be another subtheme of today's meeting, and how critically important they are and how they can be used as a monitoring metric. You got an attaboy from someone on your team, Sarah Beasley, and just appreciating your work, as do I. Does anyone else have a question? If not, I would just call people's attention to the chat where the links for this great work, and also if you have any interest in participating in that IFRMP workshop this fall. And we'll go ahead and get ready to transition to our next two speakers. Thank you again,
Actually,
Thomas and Kaitlyn.
Betsy, there is one question from Ken in there. We do have a few more minutes.
Okay.
I can just go ahead and read it.
Go right ahead.
Yeah, it's super exciting to see this long-term data set being analyzed. Are the BPAs in Mcgarvey upstream of the gauge and macro sampling reach?
Yeah, so the benthic invertebrate reach that we collect bugs from at Mcgarvey are both downstream of the Environmental Department's hydro gauge, as well as downstream of the two BDAs that Jimmy and Sarah both work on. So yeah, we can talk a long time about it, but we're really hoping to use the long-term data set that we have there in conjunction with the fisheries restoration work there to try to further look at how something like a restoration project designed for those in-stream flow restoration or fisheries habitat can impact the BMI compositions downstream. So yeah, it's exciting, and it's fortuitous. It's kind of worked out the way it was. I don't think it was quite designed like that, but we're hopefully making it work.
And then one more from Eli Asarian. Are you working on reports or publications for these excellent data and analyses?
We hope to. Yeah, myself and Mike Belchick presented a very similar presentation at the SRF just recently down in Santa Cruz, and yeah, there seems to be a lot of interest in using benthic invertebrates as far as drought indicators, not just water quality indicators. And so I'm really hoping to work with Kaitlyn and Matt and others to report on some of these incredible data sets that the tribe has and has gathered for decades, literally 2 decades worth of benthic invertebrate data from multiple tributaries is pretty amazing, and yeah, pretty fortunate to be able to work with it.
All right, well, thank you very much.
Thank you.